Hello and welcome back to the numerical analysis course series. So in today's video, we will unlock the Newton-Raphson method, a powerful shortcut that blends calculus and iteration to find the solution fast. So let's break down the Newton-Raphson method into a very simple working rule. So initially, we must have a function, say f of x is equals to 0, for which you want to find the root. Secondly, we need to find out the initial guess, or we just simply choose an initial guess. We call it S X naught. So we are going to start by choosing an initial guess close to the expected root. And this is super important because a good guess leads to a faster convergence. Thirdly, we need to evaluate f of x naught and f prime of x naught. So we will need the both function and its derivative at this point. After that, we need to apply the Newton-Raphson formula. So apply we call it NR formula also. NR is the short form of Newton-Raphson formula. So we write it like this. The generic formula would be Xn is equals to Xn minus 1 negative of Xn minus 1 divided by f prime of Xn minus 1. So in that case, our n should be equals to 1, 2, 3 and up to so on. So for the first approximate root, we have first approximate root, we have x of 1 that is equals to x of 0 negative f of x naught by f prime of x naught. Similarly, if we repeat the approximation, so our second approximate root is x2 that is x1 minus f of x1 over f prime of x1. So we will continue this process until and unless our accuracy is achieved. So we simply say that the fifth point is repeat the process until and unless required accuracy is achieved. And there you have it, the Newton-Raphson method made simple and visual. From an initial guess to a refined root, each iteration brings you closer to solving nonlinear equation with ease. So if you found this explanation helpful, hit that like button, subscribe for more numerical analysis tricks, and let me know in the comment what method would you like to explore next. Remember, in the world of mathematics, every root is just a few iterations away. So thank you so much for tuning in. Take care.